Today, we're going to start looking at applications of linear systems. So specifically today, we are going to choose the best method to solve for a system of linear equations. So since there's three methods that we now know how to solve, there's graphing, there's substitution, there's elimination. There may be directions that just say solve each system. So I'm not specifically saying you have to solve it by graphing, you have to solve it by substitution, you have to solve it by elimination. Sometimes it's going to be your choice. Therefore, understanding which of the three methods to use quickly in order to solve it the most efficiently is going to be important. So let's kind of recap and show when will I use this because it's the best method. So when is graphing the best method? So the only time that I would suggest if you are given the choice that you would graph was when both equations are in slope-intercept form. Okay, remember slope-intercept form is when it says y equals, and then it's mx plus b, where m is our slope and b is our y-intercept. So if we don't see both equations already solved for y, if you had to choose, probably graphing is not going to be the method that you want. But if both of them do say y equals, graphing is going to be the best method. So when is substitution the best method? Well, substitution is the best method when one equation has a variable by itself So that means that you see an equation that says x equals, or you see an equation that says y equals. Okay, so one of those equations has a variable by itself, or there is one variable with a 1 in front, that could easily be isolated by itself. Because remember, in order to do substitution, we want to have a variable by itself. So automatically, if I see one equation and it's x equals, or I see one equation and it's y equals, substitution should be the route you go. But if you don't see a variable by itself, but you notice that there's a 1 in front, it's very easy to get a variable by itself if there's a 1 in front. You just have to move the other term over to the other side. So that's when I would use substitution. When would we use elimination? Well, we'd use elimination when all like terms are lined up vertically And so that means that you've got all the x's together lined up nicely. You've got all the y's lined up nicely. You have the equal signs lined up nicely. You have the number on the other side lined up nicely. So when all like terms are lined up vertically and we have opposites. So that means that one of our variables like x, say like one of them is a negative 2x and the other one is a positive 2x. Those are opposites. Remember, elimination, we're trying to cancel something right away. So if they're already opposites, then bam, they are gone. We're good to go with elimination. Okay, if we see like terms lined up vertically, but we don't necessarily have opposites, so we can then easily multiply to get opposites. That's when we would want to use elimination. Okay, so we're going to run through some examples and I'm going to once again explain my reasoning as to why we would choose either graphing, substitution, or elimination. And then that's what you're going to do for homework. Several of the problems, I'm just going to ask which method would you choose. I'm not going to ask you to solve. Then you're just going to justify your reason. But then, of course, this is math. You are going to have to solve a little bit. So then you'll be given a couple of them and you'll be trying to determine the best method. So notice the directions say solve each system and explain why you chose the method you used. So notice that in this first example, 3x minus 5y equals 16 and 6x minus 10y equals 9. I don't see both equations that say y equals. So that means that I'm not going to graph this. So even though there's a graph provided, I'm not using it. If I look, I do not see a variable by itself. I don't see x equals. I don't see y equals. Notice that in front of the first x is a 3. In front of the first y is a -5. The next x is 6. The next y is -10. So I don't even see any positive ones where I could potentially get a variable by itself. However, notice that I've got all the x's lined up, all the y's lined up, the equal signs lined up, the numbers lined up. So this tells me that elimination is the route that I should choose. And so the reason why I'm choosing elimination is because the like terms are lined up. So that's really the gist of that one, okay? Like terms are lined up. So now I'm going to actually solve it, but I've explained why I'm choosing the method I'm choosing. So if I look at the x's, remember, I want to try to add these up and have something disappear right away. Well, 3 plus 6, that's not going to turn to 0. If I look at -5 plus -10, that's not going to turn to 0 either. So unfortunately, I can't just add them up right away. But if I look at my smaller number of 3, can I multiply it by something to get the opposite of 6? And my answer is yes. The opposite of 6 is -6. I can multiply 3 by -2. 3 times -2 is -6, and then I'll have my opposites. So I'm going to multiply the entire top equation by -2. So 3x times -2 is -6x. -5y times -2. Well, a negative times a negative would make that a positive. It's 10, and there's a y with it. That's going to equal 16 times -2, which is -32. I get to keep the bottom equation as it is because we didn't have to multiply anything by that. And now, because we have opposites with the x's, we get to add up our like terms. So notice that -6 plus 6, those x's go away. If I look at the 10y plus -10, those are actually opposites now as well. So that goes away. So all of the terms on the left side disappear. So I'm left with 0. On the right side, -32 plus 9, that's -23. So notice that using elimination, all the variables disappeared. 0 does not equal -23. That is a false statement. So that means my final answer is no solution. Okay. If we take a look at the next example, I have y equals 2x plus 3, and I have y equals 1/3 x minus 2. Notice that in this, it says y equals on the top, and it says y equals on the bottom. So what's the best method? Well, it would be graphing. And the reason why graphing is the best method is because both equations are in the y equals mx plus b form. Okay, they're all in slope-intercept form. So notice that means that we've got two equations. I'm going to go ahead and because I'm graphing, I'm going to identify the slope and the y-intercept. So in the top equation, notice that the number connected to x is 2. So 2/1 is my slope. 3 is positive. That's my y-intercept. So 0, 3. So I'm going to go ahead and graph this first. So this is why the graph is here. I want to graph. So I start on the y-axis at 3. Slope, because it's positive, I can move up and then to the right. So we're going up 2 and then 1 to the right, up 2, 1 to the right. I can do that multiple times. If I want to go in the opposite direction, I'd have to go down and then to the left. So from that 3, I can go down to 1 to the left, down to 1 to the left. I can keep doing that as many times as I want. And then now I can very carefully connect those points, and there's my first line. So now if I'm looking at the second equation, the bottom equation, I want to identify the slope. I want to identify the y-intercept. Well, the number that's connected to the x is my slope. That's 1/3. The number that is not is -2. So as an ordered pair, that's 0, -2 for my y-intercept. So I'm going to go down to -2 on the y-axis. My slope being positive means I can go up and to the right. So I can go up 1 and then 3 to the right, up 1 and 3 to the right, okay? Or I can do the opposite. I could go down, but then I'd move to the left. So I could go down 1 and then 3 to the left, down 1, 3 to the left. I can do that as many times as I want. So notice that when I connect those points to form this line, I see that the 2 lines intersect, which means that we will have a solution. We have one solution. It's the ordered pair where they intersect. So if I'm looking at this point right here, I go to the x first. It's lined up nicely with -3. And then I go down to the y, which that's lined up nicely with -3 as well. So my solution is -3, -3. If I take a look at this third example, we've got -x plus y equals -13. And we have y equals 3x minus 19. As you can see, this bottom equation has a variable by itself. The top does not. So that indicates that we want to do substitution. And that's because we have one variable by itself. So we don't need the graph. It's there only if we chose to graph. This time I'm not. So because I know what y equals, I'm going to substitute that into the y in the top equation. So we'll have -x plus, I like to substitute it in parentheses. So in parentheses, I substitute in my y, finish the rest of the equation, that equals -13. Because there's no number in front of the parentheses, it's technically a 1. If I was to distribute a 1, it's not going to change anything. So I can, in this case, drop the parentheses. I've got several like terms on the same side, so I'm going to combine those into 2x. We still have -19 equals -13. I'm going to then add 19 over to the other side. That gets rid of it there. We have then 2x equals 6. I'm going to divide by 2, and we get x to be 3. I'm going to go back to the equation where I have my arrow. So y equals, we'll have 3 times now 2 minus 19. Well, 3 times 2 is 6. 6 minus 19 is going to give us a value of negative. Did I mess up? No, sorry. This should be a 3, not a 2. I'm sorry. So that's 3. This is really 9 minus 19, which will give us a -10. So my solution, as an ordered pair, is 3, -10. So that's how you choose the best method. If you notice here, this checkpoint problem, it just says explain which method you use to solve. No need to actually solve. Like I said, that's going to be your first couple of problems in your homework. Hopefully you notice that, hey, all the x's are lined up, all the y's are lined up, all the equals are lined up, all the numbers are lined up. I don't see y equals for both of them, and I don't see a variable by itself. So hopefully we're okay with this one has to be elimination. And once again, that's because like terms are lined up.